All right, so let's talk about what is a matrix. All right, so a matrix, it's really simple actually. It's just a rectangular array of numbers. It has a certain number of rows and a certain number of columns. All right, that's it. All right, it's just a rectangular array of numbers. So it's always going to look something like this, right? Like this matrix, we call this matrix A. This has 4 rows and 4 columns. It's a square. And there's a bunch of numbers in it. This is matrix B. It has 3 rows and 2 columns and has a bunch of numbers in it. It's not a square matrix, right? It's a rectangular matrix. And then here we have matrix X. And this is filled with variables, but variables are just numbers that we don't know, right? So that's totally allowed. So here, right, x11, x21, and you can see the first number is indicating the row of that matrix, of that variable, and the second number indicates the column of that variable, right? So like xm2 is the mth row and the second column, right? Vice versa, x2n is the second row down and the very last column, the nth column. And so you can tell by looking at this matrix that it has m rows and n columns. That's it. That's all there is to know what a matrix is. Now let's talk about a vector. A vector is a one-dimensional matrix. All right? So it's like this. There's 2 kinds of vectors. We have a column vector and a row vector. A column vector looks like this. It's a single column. So this one has 5 entries, but it's only 1 column wide, right? There's only the 1 column there. There's no other columns. So it's just a matrix that has only 1 column. A row vector, same thing, except it's a row. So there's only 1 row here, right? The row vector has 1 row and a bunch of numbers that go across. That's all a vector is. It's just a one-dimensional matrix. So let's go back through and talk a little bit more about matrix dimensionality, right? We said we specify the dimension of a matrix by saying how many rows and how many columns it uses, right? Now, because we're mathematicians, we like to be fancy, so we have a special notation that we use to make us seem fancy, okay? And it's this. We say this matrix A, this fancy weird-looking E, this weird-looking R, and then M cross N, okay? So what this means, this E is an epsilon, which is a Greek letter. It just means is an element of, or is in, sometimes we'll say. And then this big fancy R just means a real number, right? 1, 2, 1.5, -4, all real numbers. Pi is a real number. It's irrational, but it's still a real number. And then we just say that m by n, those are the rows and columns, right? So this matrix has m rows and n columns, right? So we say matrix A is an element of R m by n, is how we say that. So like here, matrix B, right? There's 3 rows, there's 2 columns, they're all numbers. So we say matrix B is an element of R 3 by 2. All right? You can also say matrix B is in the reals that are 3 by 2, something like that. All right? That's matrix dimensionality. So it looks scary. It's not that bad. So now I want to take a second to talk about matrix and vector notation. How do we write that something is a matrix or vector? All right? Now, if you go and look online, in textbooks, anywhere, you're going to see a whole lot of different things. All right? Everybody writes these things a little differently. Some people put arrows over the top. Some people put a half an arrow to indicate a vector. When some people write vectors, they mean a row vector. Some people mean a column vector. It's all over the place. Okay? So right now, I'm going to tell you guys exactly how I write them, and I will never write them any differently. And you can trust me that when you see it, it means exactly what I'm about to tell you. If it doesn't, then let me know because I made a mistake. All right? So here's my personal notation. A capitalized bold letter is a matrix. A lowercase bold letter is a column vector. Okay? If I want to write a row vector, I use something called the transpose, which we'll talk about in another video. But anytime you see a capital bold letter, like this A here, I mean a matrix. If you see a lowercase bold letter, I mean a vector. And not just any kind of vector, but a column vector. Okay? It's really important to try and remember that. And remember that everyone does it a little differently, but this is how I'm going to do it. All right? So then the last question is, why do we use matrices? Right? We just showed you all of this stuff that's just holding numbers. Why do we use them? So first, using matrices and equations allows us to write some complex calculations really easily. What do I mean by that? Well, it's kind of hard to say without getting into nitty-gritty specifics, but basically it means you can take like a lot of numbers and a lot of calculations that you might have to do, and you can just write it with a single letter, a big capital A. Poof, just like that. And you can actually manipulate that kind of like you would with a standard variable in a standard equation, and it can be really useful to do it like that. Sometimes it's helpful to store information in a table, right? So think about like an Excel spreadsheet. Think about that kind of like a big matrix, right? And maybe the row is something like a customer, and the column is a product, and a 1 means that that customer ordered that product, and a 0 means that they didn't, right? Something like that. And you can store a lot of information in that table as a matrix, right? Vectors, they can be useful for those previous things, but they can also sometimes represent positions on a graph, right? We sometimes say vectors have both magnitude and direction. If you think about the character in Despicable Me, he says that, right? And you can always remember, that's always how I remember it. Vector, he has magnitude and direction, right? And so it can represent some sort of position on a graph. And there are so many more reasons beyond just these that matrices and vectors are really useful. Okay, so I promise your teacher is not just asking you to learn these because they want to torture you. There's actually a lot of really good reasons behind it. And if you stick with me through a lot of other videos, we'll see more specifically how these can be helpful. And we'll also see in some of the next videos how to use these things in different ways to manipulate equations and get things that are really useful. All right, thanks for watching. I'll see you next time.